ओके ठीक है।
ओवर टू यू विपिन सर, स्टार्ट कर
ठीक
दीजिए।
है। Good evening to everyone. So today we will start coordination chemistry. Coordination chemistry, right? Topic that we have to learn in coordination chemistry are, first we will start from ligands and their classification, right? Ligands and their classification. Then second step, second topic, will theories of bonding. Theories of bonding in coordination complexes. Theories of bonding in coordination complexes, right? What are the theories? We have to study about Werner theory. Werner theory. Second one is BBT, that is called valence bond theory. Third one is crystal field theory. And fourth one is the molecular orbital theory, right? These are the four theories which are used in order to explain the bonding in coordination complexes, right? Another subtopic within coordination chemistry is color and electronic spectra. Color and electronic spectra. Here we have to learn about what are the reason for color in coordination complexes and what are the electronic spectra of coordination complexes, right? For color, we have to learn about degree transition. The degree transition, one of the major reason for color in coordination complexes. Another one is charge transfer. Charge transfer, which are mainly of four type, right? One is the LMCT, that is called ligand to metal charge transfer. Another one is MLCT, that is called metal to ligand charge transfer. Another one is IVCT, that is called intravalence charge transfer. Another is also that is common in, mainly common in biomolecules like hemoglobin, myoglobin, cytochromes, uh, chlorophyll, right? Vitamin B12, right? That is called intra-ligand charge transfer, ILCT. This type of transition is common where? Common in hemoglobin, myoglobin, cytochromes. What is the function of hemoglobin? Anyone? What is the function of hemoglobin?
Oxygen carrier.
Oxygen carrier. Myoglobin? Function of hemoglobin is, this is oxygen carrier, right? Myoglobin what? Oxygen storage, right? What is the function of cytochrome? All these are the iron containing system, right? Hemoglobin, myoglobin, cytochromes. In bioinorganic chemistry, all these topics they will cover there. Cytochromes, what is the function of cytochrome? The function of cytochrome is the electron transfer, right? One of the cytochrome named cytochrome A3 found in cytochrome B complex, right? That is an enzyme is called enzyme named cytochrome C oxidase, right? Cytochrome C oxidase, one of the enzyme found in mammals. Cytochrome C oxidase. Within cytochrome C oxidase, that is the subunit of cytochrome C oxidase is cytochrome A3. This cytochrome A3 is responsible for cyanide poisoning, right? So cyanide poisoning is not due to blockage of activity of hemoglobin or myoglobin. It is due to blockage of activity of cytochrome C oxidase, and it binds with one of the subunit of cytochrome oxidase named cytochrome A3, which prevent further reduction of dioxygen. Right? In cytochrome A3, there is binding of dioxygen, and it is responsible for reduction of, it helps in the reduction of O2 to water. When cyanide bind with cytochrome A3, then conversion of O2 to water is reduced. It means it is the stopping of oxidation of food, that is generation of energy, that is the blockage of electron transport system or electron transport system in mitochondria that leads to immediate death of any living organism, right? So in cytochromes, also in cytochromes, the color. The reason for color is mainly what? Intra-ligand charge transfer, right? Another is vitamin B12. These are the biomolecules. In these molecules, also color is due to because of it. D9, right? These topics we have to study in subtopic of coordination chemistry, that is color and electronic spectra. Is it clear?
Yes,
Right?
sir.
Okay.
Yes, sir.
Yes, sir.
Now another topic, the coordination chemistry is the magnetism, right? In magnetism, we have to study about diamagnetic system. What are the diamagnetic systems? And paramagnetic system. Another is ferromagnetic, right? Ferromagnetic and rules associated with ferromagnetic system. That means Curie-Weiss law, ferromagnetic, ferrimagnetic, right? And another is anti-ferromagnetic systems, anti-ferromagnetic compounds. Another most common thing, the most common topic, most common question which is asked from the magnetism is from the another topic is called magnetic susceptibility, right? Magnetic susceptibility, right? Paramagnetic susceptibility. Also, another thing that we have to study in magnetism is orbital, that is, we can say magnetic moment, right? Magnetic moment is of, that is the overall magnetic moment in any system is mainly from two type of motion. One is the spin motion of electron, another is the orbital motion of electron. That means overall magnetic moment of any coordination complex is because of spin motion, which is called spin magnetic moment, and due to orbital motion there is another moment that is called orbital magnetic moment, right? Orbital magnetic moment in many complexes, especially in coordination complexes, there is disappearance of orbital magnetic moment because of presence of ligand. I will uh, tell you these topics completely or in depth when we will learn about magnetism, or we will learn the subtopic of magnetism. For the orbital magnetic moment, the quenching of orbital magnetic moment. Another topic that emerges from the quenching of orbital magnetic moment is the orbital contribution to the magnetic moment. That is a very important topic of magnetism. Orbital contribution to the magnetic moment. Right? These are the topic that we have to study in the subtopic magnetism of coordination chemistry. Right? Another is the isomerism right? And IUPAC nomenclature. IUPAC nomenclature. In isomerism, we have to study about two type of isomerism. One is the called constitutional isomerism, another is called stereoisomerism. Constitutional में हमें पढ़ना है linkage, right? Ionization. There is nearly seven type of isomerism in constitutional and two type of isomerism in stereoisomerism, that is symmetrical isomerism and optical isomerism, right? Another topic we have to study about thermodynamic and kinetic stability. Thermodynamic and kinetic stability of coordination complexes. Kinetic stability of coordination complex. It means coordination chemistry is the major topic of inorganic, right? ठीक है? These are the topics that we have to study in coordination chemistry, right? So today I'm going to start with this ligands and their qualification. Before explaining about ligand and their classification, I would like to tell you about basics of coordination chemistry. That what are the coordination complexes? How will you differentiate between any normal complex and coordination complex, right? So यहाँ से हम लोग शुरू करते हैं कोऑर्डिनेशन केमिस्ट्री, right? When two solution or two or more than two solution are mixed, for example, when A and B, for example, are mixed, then there is formation of two type of compounds, right? When two type of salts are mixed, A, B or C, it means when two or more than two salt are mixed, then there is possibility of formation of two type of compounds. One is called double salt, right? And another is called coordination complex. Coordination complex. What is the difference between double salt and coordination complex? In double salt, each ion on dissolving in any solvent loses its identity. It means what are the properties of double salt in normal cases, right? When it dissolved in a particular solvent, then all the ions of the double salt will get dissociate into that particular solvent. It means we can say all the ions loses their identity. In case of coordination complexes, all the ions, in case salt A, salt B, salt A, salt B, all the ions do not lose their identity. For example, the most common double salt is Mohr salt. Yeah, we can say the K2SO4, Al2SO4 whole thrice 24H2 potash Lm, right? Right? This is called on dissolving in water solvent, it get dissociated into 2K plus 4SO4 2 minus 2Al3 plus. It means on dissolving in water, each ion, I mean potassium, sulfate, aluminum, all these ions, K2, SO4, Al2, these ions get dissociates like this. 2K plus SO4 2 minus Al3 plus. And this solution will give test of potassium, sulfate, as well as aluminum. Right? In case of coordination complexes, for example, FeCN6 4 minus. This is the complex ion. On dissolving in water, there will be no reaction. It means neither there is formation of iron 2 plus, neither there is formation of Cn minus. It means the solution of FeCN6 4 minus in water neither give the test of iron 2 plus, neither give the test of Cn minus. That is the difference between double salt and coordination complexes. In double salt, each ion on dissolving in a particular solvent will convert into its constituent yeah, it means elementary state. That means potassium become K2SO4 will break into 2K plus SO4 2 minus, Al2SO4 will break into SO4 2 minus and Al3 plus, and the solution of double salt will give the test of potassium sulfate Al3 plus. However, in case of coordination complexes, all the ion do not lose their identity. For example, efficiency is 4 minus on dissolving water, neither give the test of iron 2 plus, neither give test of Cm. That means in water or in many solvents, this particular complex ion do not dissociate in its constituent ions. That is the difference between double salt and coordination complexes. Why this is so? Because there is formation of coordinate bond between iron and Cn, and coordinate bond is of type of coordinate bond is a type of covalent bond. Coordinate is a type of covalent bond, right? And all of you know that covalent bond do not dissociate easily in polar solvent. Is it clear? Covalent bond, right? Coordinate bond is a type of covalent bond, and complexes or molecules where there is covalent bond between two species, it means the bonding nature, it means the nature of bonding between this system and this system is a type of covalent type, and covalent molecule do not dissociate easily, right? Hence, no dissociation, right? Is it clear? Same example is NH4 to SO4, FeSO4 dot 6H2O. This is called Mohr salt. Mohr salts is also example of double salt. On dissolving in water, it will dissociate into NH4 plus, 2NH4 plus, SO4 2 minus, iron 2 plus. It means the solution of Mohr salt in water will give the test of ammonium ion, SO4 2 minus ion, Fe2 plus ion. Similarly, if we take another example, CuNH3 4 2 plus, this complex on dissolving in water, neither it generate copper 2 plus, neither it generate ammonia. It means this complex is example of coordination complex, and this complex do not dissociate into water in copper 2 plus and ammonia. It means this is the example of coordination complex. It means there is covalent type or coordinate type. Covalent coordinate is same, right? There is coordinate type of bonding between copper and ammonia. That is why there is no dissociation of CuNH342 plus in water. This is the difference between coordination complexes and double salt. Is it clear? Bonding in these cases, in air and air, bonding in these cases is of ionic. That's why they undergo dissociation. Bonding between coordination complexes is of coordinate bonding. That is, it is a kind of covalent type of bonding. It means there is sharing of electron between two species. That is why they do not dissociate in polar solvent. It means they retain their identity even in a particular solvent. Unlike those of double salts, in which all the ions lose their identity when they are dissolved in a particular solvent. Is it clear?
Yes, sir.
Sir,
Okay, आगे चलें?
yes, sir.
Now I am going to start with ligands, right? First we have to learn about ligands. And all of you have to learn the ligands which today we will study, so that in the coming classes there will be no problem in understanding any type of complex, so that all of you understand what is the name of complex, what is the nature of ligand, what are the donor atoms of ligand, so that we can easily extend its delta value, why delta value of that particular ligand is higher or smaller, and what is the nature, it means what is the nature of that ligand, what are the stereochemistry that comes from that particular ligand, and also we can also predict about the thermodynamic and kinetic stability, right? So it is very important to learn all ligands which are today we are going to study. So what are the ligands? Any species which can donate at least one electron pair, right? Electron pair can be of bond pair, electron can be of lone pair, right? Can we have as ligand? तो क्या लिख सकते हैं? Any species which can donate at least one electron pair. That electron pair can be lone pair or bond pair. Lone pair or bond pair can we have as ligand, right? Can behave as ligand. For example, water can behave as lone pair. Acetylene can behave as lone pair because it has pi electron pair, right? Pi electron pair. Ethylene. Acetylene can behave as lone pair because it has two pi electron cloud. Benzene can behave as ligand. There is donor electron is pi electron. Here also pi electron, here also pi electron. Here is the lone pair. Ammonia can also behave as, right? Can BF3? No. And because in BF3 boron has neither any electron pair, neither lone pair nor bond pair. It has sigma bond pair, but sigma bond is very strong bond, so it is not easy to donate or share with any species. Pi electron clouds are loosely held, that's why they can be shared with any other systems, right? ETC are the example of, तो इसको ध्यान रखना कि cannot be able ligand, right? And then we are now classification of ligands. Classification of ligands. Ligands are classified in two categories. First category is on the basis of number of donor atom. On the basis of number of donor atoms, that is called denticity. On the basis of denticity, right? Yeah, we can say on the basis of denticity. The basis of denticity. And then there is the classification on the basis of specific kind of bonding or specific behavior. On the basis of specific behavior of ligand, right? In this category, we will learn about monodentate, bidentate, tridentate, tetra, penta, hexa. And in second category, we will learn about bridging ligand, right? Ambidentate ligand, flexidentate ligand, chelating ligand, macrocyclic ligand, right? In this case, ambidentate, flexidentate, chelating, macrocyclic, symmetric, asymmetric, bridging, all these categories comes in second part. And in first category, we will learn about monodentate, bi, tri, tetra, penta, hexa, hepta, octa. So first, we will learn about classification of ligand on the basis of number of donor atom, right? First, classification on the basis of number of donor atom, on the basis of denticity, right? So first one is the monodentate ligand. Monodentate ligand. Monodentate ligand कौन सा ligand है? Those ligands which are attached to metal via one donor atom, right? Any ligands which is attached to metal via one donor atom is called monodentate ligand, right? Simple, any ligand which is attached to metal via one donor atom, attached to metal via one donor atom. One donor atom is called monodentate ligand. Dentate ligand. It is also possible then. It is also possible that there are many ligands which have more than one donor atom, but during bonding they are attached to metal via only one donor atom. It means they are not bidentate or tridentate. They are only monodentate. It means it is nothing. It is not important for any ligand that how many donor atom it has. It is important that via how many donor atom it is attached to metal, right? For example, NH2, NH2. For example, NH2, NH2, right? It has two donor atom, this one and this one, but it is not bidentate. It is monodentate only because at a particular time, all both these nitrogen atoms do not involve in bonding with metal, right? So it is important that via how many donor atoms any ligand is attached to metal. It is not important that how many donor atom any ligand has. Is it clear? Right? Is it clear? It is
Yes, sir.
not important during classification. It is not considered that how many donor atoms in any ligand has or present. It is important that how many donor atoms are attached to metal during bonding, right? That is counts in density, not the number of donor atom. Okay. Now we will see the examples of monodentate ligands. Neutral monodentate, just negatively charged monodentate ligand. Negatively charged. These are the example of monodentate ligands. Now all these example, all of you have to learn monodentate ligand. Here I am going to write the name of the ligands which are used during nomenclature so that it will be easy for us that during explaining nomenclature we will only focus on nomenclature, not many times we have to write the name of the ligand, what are the ligand, name of the ligand. So after that we have to write nomenclature. So here only I am going to discuss. I am writing the name of the ligand. That is the name that is used used during IUPAC nomenclature, right? For example, Cl minus chlorido, right? F minus fluorido, Br minus. These are the names that we will use when we will learn about IUPAC nomenclature, right? Br minus is called bromido. I minus, that is called iodo. O2 minus, that is called oxido or sometime oxo. NH2 minus, that is called amido. NH2 minus, that is called imido. N3 minus, that is called nitrido. OH minus, hydroxo, right? H minus, hydrido. These are the names which are used when we write the name of any coordination complex, right? NO2 minus N. NO2 has two type of bonding capacity. One is nitrogen, another is oxygen. When it is write like NO2 minus, that is called nitrito N. It means when NO2 minus bind with metal via nitrogen donor atom, then it is called nitrito N. When it is bind with metal via oxygen donor atom like this, then this is called nitrito O. Nitrito O, right? SH minus thio A, like this. H2 minus sulfido, right? CO3 2 minus carbonato. Here, carbonato. NO3 minus nitrato. SO4 2 minus. This is called sulfato. Right? ClO4 minus. It is also example of monodentate ligand. It's called perchlorato. Right? PO4 3 minus phosphate. It's called phosphato. O2 minus. This is called superoxo. O2 2 minus. This is called peroxo. Right? SCN. SCN is also two type of bonding tendency. One with sulfur atom. When it is written like SCN, this is called thio. It means when SCN minus is bonded to metal via sulfur, this is called thiosulfato S. When SCN minus is bonded to metal via nitrogen, then this is called thiosulfato N. Right? Cn minus cyano or sometimes cyanido. Most commonly cyano is used during nomenclature. Cyano or cyanido. MeO minus methoxo. Methoxide is called methoxo. H2O3 2 minus thiosulfato. SO3 2 minus sulfito. These are the common negatively charged monodentate ligand. Right?
Sir, I have one doubt.
Hello.
Hello, हाँ
Sir, I
बोलिए.
have, sir, the SCN minus is thiocyte.
Ah,
Both are thiocyte
thiocyanate. Yeah, yeah.
Where?
in SCN minus.
When SCN is bonded via nitrogen donor atom, like this. When MSCN, then thiosulfato S. When MNCS, then thiosulfato N.
Here
Right?
S2O3 2 minus is also having same name. Thiosulfate. Here it is also having thiosulfate. Both are same
Is
name.
it one minute? Okay, okay, okay. Oh, right. Yes, 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 yes. Thiocyanate. Okay, okay. Right. Thiocyanate. बिल्कुल. The thiocyanate. Right?
Yes, sir.
Okay. आगे चलें. These are the common negatively charged monodentate ligand, right? Now we will come on neutral monodentate ligand. Neutral monodentate ligand. Ammonia. During nomenclature, we have to write amine. Okay. Water. Nomenclature, we have to write aqua. CO. For CO, we have to write carbonyl. CS, we have to write thiocarbonyl. Right? NO, we have to write nitrosyl. For NS, we have to write thionitrosyl. Okay. PCS3 thrice. This is called trimethylphosphine. Trimethylphosphine. At the place of CS3, we will take C6H5, then this is called triphenylphosphine. Triphenylphosphine, pyridine. Pyridine also example of monodentate ligand, pyridine. In short form, pyridine is written as PY, right? NH2. It has two donor atom, but it is the monodentate ligand. It's called hydrazine. Only one donor atom is involved in bonding. NH2OH. In NH2OH, only nitrogen atom is involved in bonding with metal. It's called hydroxylamine. Hydroxylamine, right? This is CS3 to NH. It's called dimethylamine. It is also example of monodentate ligand, which is neutral. CS3 thrice N. This is trimethylamine. Is also example of monodentate ligand, a neutral monodentate ligand. Listen, in organic amine, it is double M is written, right? However, in case of organic amine, single M is used for writing the name of amine. The organic fragment, that is single M. Inorganic fragment, that is why double M. Okay. Another most common example of monodentate ligand, a neutral monodentate ligand is this. Only one of nitrogen it attaches to metal via bonding, during bonding. This is called pyrazine. In short, it is written as PZ. These are the common example of monodentate ligand. The neutral monodentate ligand, right? Also, nitrogen is also behave as monodentate ligand. O2 also behave as monodentate ligand. This is called dinitrogen. This is called dioxygen. Ether also behave as monodentate ligand. C2H5O, C2H5, that is commonly called diethyl ether. These are the common monodentate ligand. Okay. आगे चलें?
Yes, sir.
Okay. Third one is the positively charged monodentate ligand. Positively charged monodentate ligand. सबको याद कर लेना आप लोग, ठीक है? जितने भी लिगेंड्स लिखवा रहे हैं, जिससे कि जब हम बॉन्डिंग पढ़े या अदर टॉपिक पढ़े तुम्हें प्रॉब्लम ना हो. ओके, सो इट इज नेसेसरी फॉर ऑल ऑफ यू दैट all of you learn all these ligands, either monodentate, which are negatively charged, positively charged, neutral, and also bidentate, tridentate, pentahexa, and also the short form of the ligand. It means how they are represented in complexes, so that we can learn, or it will be easy for us to understand any complex, and also the behavior of complex that is based on crystal splitting, kinetic stability, thermodynamic stability, also its isomerism and nomenclature too, right? Very less, there are very less example for positively charged monodentate ligand. One of the most common is the NO plus, that is the nitrosonium ion. Nitrosonium ion. Another is the NH2 NH3 plus. This is called hydrazinium ion. It is also example of positively charged monodentate ligand. Here donor atom is not nitrogen. It is also donor atom is the nitrogen. Right? These are the common positively charged monodentate ligand. Example of positively charged monodentate ligand. Right?
सर NO प्लस का स्ट्रक्चर आप एक बार बता दीजिएगा.
हाँ, okay. NO plus is formed when there is removal of one electron from NO, then it is the formation of NO plus, right? Bond order of NO is 2.5, and bond order of NO plus is 3. So structure of N triple bond O is positive charge on nitrogen, and there is one lone pair. So electron is dominated by the nitrogen, not by oxygen, right? This is because of high energy. One lone pair is also there. This lone pair is present on more electronegative atom. That is why it is of low energy electron, right? Low energy electron. An electron which is present on more electropositive atom is high energy electron. High energy electron. That is why during bonding, it is nitrogen which is involved in donating electron to the metal, right? Is it clear? And
Yes.
NO can exist also as NO minus, right? There, the bond order will be 2.0, and in NO, there will be double bond between nitrogen and oxygen, and one lone pair is there, one pair is there. In term of hybridization, if we wish to write the hybridization of nitrogen, then hybridization of nitrogen in NO plus will be sp, because one lone pair and one sigma bond, that is sp. Pi bond is not counting during hybridization. Here, in case of NO minus, if we write the hybridization of nitrogen, then it will be 1, 2, 3, that is the sp2. It means in NO minus, hybridization of nitrogen in sp2, and in NO plus, hybridization of nitrogen is sp. That is why it is linear, and is it non-linear? Non-linear in term of lone pair, right? Or linear mode binding show करता है, linear mode binding because of sp hybridization, it show bent mode of binding. Bent mode binding because sp2 hybridization. Is it clear?
हेलो सर।
हाँ बेटा बोलो।
सर ये जो पॉजिटिव चार्ज है वो ऑक्सीजन पे नहीं होगा इसमें जब
नहीं
आपने
नहीं नहीं,
जो
देखिए पॉजिटिव चार्ज आप जनरली उस पर रखा करिए जो मोर इलेक्ट्रो पॉजिटिव एटम, राइट? इट इज कॉमन दैट पॉजिटिव चार्ज मेनली लोकलाइज्ड ऑन more electropositive atom and negative charge is mainly localized on more electronegative atom, right?
सर जैसे
Because
नाइट
हाँ बोलिए बोलिए बोलिए।
सर नाइट्रोजन के आउटर शेल में 5 इलेक्ट्रॉन है तो सर ये 3 तो इसने बॉन्डिंग में कर लिए फिर
No, actually there is one kind of bonding is called coordinate type, right? Like this, right? It is understandable that one is the coordinate type of bonding, like this. ठीक है?
ओके सर।
एंड नाइट्रोजन जब भी ऑक्टेट पूरा करता है, हर 3 बॉन्ड बनाता है, तो ऑलवेज पॉजिटिव चार्ज रहेगा इफ इट इज लोन पेयर। ओके, मतलब इन दिस टाइप ऑफ बॉन्डिंग either 5 bond, and also there is possibility of one coordinate bond, and 4 bonding, and if there is 4 bond, it means one lone pair and 3 bond, then nitrogen will have one positive charge. Then it means that one of 3 bond is of coordinate type, right? So 5 electron is present on nitrogen, one positive charge, it means it has 4 electrons, the 2 electron is there, 2 electron is there, one is the coordinate bond from oxygen to nitrogen, right? आगे चलें?
ओके सर।
Okay. Nitrogen can exist as NO plus, where bond order is 3. Nitrogen can exist as NO minus, where bond order is 2.0. The present, nitrogen as NO plus, nitrogen as NO minus is mainly important in coordination chemistry, or much more important in organometallic chemistry, where we have to satisfy the 18 electron rule in order to understand that whether nitrogen is present as NO plus or nitrogen present as NO minus. But in many coordination complexes, many common coordination complexes, nitrogen exists as NO plus with iron, right? Listen, nitrogen NO exists as NO plus in many iron complexes where iron is present in low oxidation state. It means there are many complexes of iron where iron is present in low oxidation state. NO exists as NO plus. Why low oxidation state is required? Because NO plus is already electron deficient. So it will exist, or NO will show its NO plus type of behavior only when it is attached to those metal which are electron rich. And for any metal to be electron rich, it is the first condition that it will have low oxidation state. Another condition is also that it should have electron. Also, it should be low oxidation state. Because if any metal has more electron, it means if any metal has more electron density but also high oxidation state, then electrons of such metal will be tightly held because of more nuclear force. Therefore, although metal has more electron density, but due to high nuclear force, it will not be able to donate the electron deficient surroundings. That means NO plus. मतलब ये है कि it is also necessary for any metal for donating electron to any electron deficient or pi acceptor ligand. It should have more electron density. Also, it should be present in low oxidation state, because if it has more electron density but metal is present in high oxidation state, then in high oxidation state, the nuclear force will be high, electrons will be tightly held. In such condition, metal will not be able to donate electron to the electron deficient surrounding, although it has more electron density. It is similar to that of we have 10 lakh rupees but in bank accounts, so that we cannot donate to single penny to any vikari. It is like that, right? So both these conditions must be satisfied for iron. That means it should be in low oxidation state. Also, it should be electron rich. Is it clear? क्योंकि
Yes, sir.
मान लीजिए कि
Yes,
मान
sir.
लीजिए इलेक्ट्रॉन
Yes, sir.
इलेक्ट्रॉन है लेकिन दे ही नहीं सकता, तो क्या करेगा फिर? Right? Why low oxidation state? Because NO behave as pi acceptor. NO is NO plus, it is electron deficient, so it will prefer to iron in those oxidation state in which iron will be electron rich. Also, iron should be in low oxidation state, right? For example, one of the most common example of iron complex in which iron exists as NO plus is the FeH2O 5 NO2 plus, right? In this complex, NO exists as NO plus. Then what will be the oxidation state of iron? Oxidation state of iron will be +1, right? Is it clear?
Yes, sir.
Okay. And what will be the electronic configuration of iron? Iron +1 in free state. If free state means there will be no ligand around iron plus, then it will be the Ar 3d6 4s1, right? But in this complex, because in this complex iron plus is surrounded by these 6 ligand, and iron plus 1 in this complex will be as Ar 3d7 4s0. Is it clear?
Yes, sir.
Not like this. It is the electronic configuration in free state. It means there is no ligand. Free state means gaseous state. When metal has these ligand, then first we have to fill d orbitals. After that, we have to fill s orbital. So all these 7 electrons will remain in the d orbital, not in s orbital, right?
There
If
are
we see
some
the
sort
splitting
of
of iron plus, then we can also write, or normal case, we can write 3d7 like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So number of unpaired electron will be what? Number of unpaired electron will be 3. If you will add this type of configuration in this complex, then what will be the number of unpaired electron? 1, 2, 3, 4, 5, 6,
5.
Number of what? 5. It is incorrect, right? In this complex, number of unpaired electron is 3, not 5.
Yes, sir. Yes. Sir,
Okay.
actually, so in some compounds, it happens like this 4s electron goes in 4d, like upper ones. I mean,
4s electron goes
yeah.
into
it moves to a higher energy orbitals like 4d or some, I mean, upper orbitals.
So here, instead of pairing, it will undergo some
Instead of
excitation.
going inside, it goes up. And some, like the single electron I'm talking about, sir. ये जो 4s वाला है.
in free state or in complex state.
In complex state.
Complex state, yes, sir.
Complex state D से S में नहीं जाएगा ना, because during complex formation energy of d orbital become much lower as compared to 4s. Then first we have to fill 3d orbital, after that we have to fill 4s orbital. In free state is it possible, but in case of complex is it not possible, right? That electron enter into 4s orbital leaving the 3d orbital, right?
नहीं सर, वो मैं कह रहा था कि सर कुछ में 4s के बाद चला जाता है, मतलब 4s के बाद
4s के बाद like 4p में.
हाँ, 4p नहीं सर, 4d है ऐसे कुछ में, क्योंकि या 4p में भी.
एक्चुअली सुनो वो जब अभी वो पढ़ते हैं हम लोग कोवेलेंट बॉन्डिंग, बट एक्चुअली क्या है वो एक दो एग्जांपल में ऐसा होता है, वो भी ऑन द बेसिस ऑफ देयर ज्योमेट्री, बट इज हाईली अनकॉमन. सो जब हम लोग अभी पढ़ेंगे ना वैलेंस बॉन्ड थ्योरी आगे, बीबीटी हमने भी पढ़ा था थोड़ी देर पहले, तो मैं आपको बताऊंगा वहां पर ऐसा कोई एग्जांपल अगर होगा तो, ठीक है?
ओके सर.
राइट, और रीजन बताऊंगा कि वहां होता है. और दूसरा हम ये भी देखेंगे, इज इट फीजिबल to put electron in high energy orbital in a particular complex or not feasible? Because if it is feasible in system to put any electron to high energy orbital, then that complex should show the behavior of those complexes where electron are present in high energy orbital, right? It means अगर हम किसी भी सिस्टम में इलेक्ट्रॉन को हाई एनर्जी ऑर्बिटल में पुट करते हैं तो उसका बिहेवियर भी उसी तरह से होना चाहिए जैसे कि एक ऐसे सिस्टम का बिहेवियर हो जिसमें हाई एनर्जी ऑर्बिटल में इलेक्ट्रॉन. अगर ऐसा नहीं, इसका मतलब our assumption is wrong, right?
Okay, sir.
Okay, so we will learn about that.
Okay, sir.
So, and this complex is very important complex because it is formed during nitrate test. What is called? That is Brown ring test, right? It means this complex is responsible for brown ring which is formed during nitrate test. This complex is responsible for brown ring formed during nitrate test. So it is very important. In this complex, nitrogen is present as NO plus, oxidation state of Rn plus 1. What is the electronic configuration? This is the argon 3d74s0 and number of electron in what? 3. And also we can calculate the magnetic moment because we know the magnetic moment of D block complexes is calculated from Spinelli formula, that is mu equal to Nn plus 2, right? Wherein is the number of unpaired electrons. So we can write here 3 plus 2, that means what? Root 15 Bohr magneton, right? So we can also learn about Browning test. Browning test. कुछ इंपॉर्टेंट चीजें जो साथ में नेम में आती है ना उसको देख लेते हैं हम लोग, ठीक है? जैसे ब्राउनिंग टेस्ट आ गया, तो ये एनालिटिकल पार्ट आपके एग्जाम में आता है कभी कभी, राइट? व्हाट इज द ब्राउनिंग टेस्ट? लुक, in Browning test we take nitrate salt in a test tube, nitrate salt in a test tube, and we add freshly prepared iron sulfate. I think आपने 12th में किया होगा इसे आप. Iron sulfate which should be freshly prepared. Why freshly prepared? Because after a long time iron get converted to iron 3 plus, right? In reaction there is requirement of iron plus 2 oxidation state, so iron sulfate should be freshly prepared, right? So that iron should be present in plus 2 oxidation state, because if iron present plus 3 oxidation state, then this Brown ring test will not happen. That is why during Brown ring test we always try to take, it is necessary to take freshly prepared iron sulfate, so that iron should be present in plus 2 oxidation state, not in plus 3 oxidation state, which is required for this test. Is it clear? And from side we add here concentrated H2SO4, right? concentrated H2SO4. At the junction of iron sulfate, nitrate, and H2SO4, there is formation of brown ring, right? Like this brown ring. It's the brown ring. Right? What are the reaction? Reaction we can also 3Fe2 plus. 3Fe2 plus मतलब iron 2 plus कहाँ से है? Iron sulfate 4H plus from H2SO4 and NO3 from salt get converted into 3Fe3 plus NO plus 2H2O. Right? It means nitrate oxidize iron 2 plus to iron 3 plus. There is the oxidation of iron, oxidation and reduction of nitrate, that is nitrogen. It means nitrate, here nitrate we have as oxidizing agent, and iron 2 plus we have as reducing agent. Right? Now this NO plus will react with FeH2O6 2 plus. NO ये कहाँ से है? इसी में है, ठीक है। आयरन 2 प्लस को जब डिसॉल्व करोगे तो आयरन 2 प्लस गेट equated, so that it means iron 2 plus, some of iron 2 plus will also be present as iron H2O6 2 plus. NO, this formation of Fe H2O NO, replacement of water by NO 2 plus H2O. This is the complex responsible for brown ring. Is it clear? This is the brown ring test for nitrate ion. Clear here? At the
Yes.
junction of iron
Yes,
sulfate
sir.
and concentrated H2O nitrate, there is formation of brown ring. The complex that is responsible for nitrate test during brown ring is FeH2O5 NO2 plus. Oxidation state of iron +1. Number of unpaired electrons 3. Electronic configuration of iron in this complex is argon 3d7 4s0 and magnetic moment will be √15 Bohr magneton. ठीक है? Another example of iron complex where NO is present as NO plus is the sodium nitroprusside, right? And common test called sodium nitroprusside test for sulfide, that is linked with this sodium nitroprusside test. Sodium nitroprusside is what? Na2FeCN5NO. This is sodium nitroprusside. Sodium nitroprusside. Right? Sodium nitroprusside for what? This is the test for qualitative test for sulfide ion. Right? In this complex, NO is present as NO plus. NO is present as NO plus. And what will be the oxidation state of iron? बताइए आप लोग. What is the oxidation state of iron?
+2.
+2, बिल्कुल exactly. This will be 2Na plus FeCN5 NO 2 minus. Then what will the oxidation state? X minus 5 plus 1 equal to -2. X minus 4 equal to -2. X equal to +2. The oxidation state of iron is +2. Right? It has a red color. Sodium nitroprusside is red color. If, for example, if we have a test tube and in test tube there is presence of H2 minus, then on addition of, for example, is named A means sodium nitroprusside, then color of the solution will turns into purple or violet color. Right? Purple or violet. This is the test for sulfide ion. It means sodium nitroprusside compound used for qualitative test of or presence of sulfide ion in any system. Right? On addition of sulfide ion, there will be Na4, 2Na plus Na4, FeCN5, NOS. Here also oxidation state of iron involved, +2. And what is the charge in NOS? NO plus is what? In Na2FeCN5, NO is present as NO plus. When NO plus react with H2 minus, then it will be NOS. The NOS will have charge of minus, right? +1, 2 minus, what will be charge remaining? -1, right? So -1, this will be -6, -4. So oxidation state of iron will be +2. Here also +2, here also +2 with purple color, purple or violet color. This is the confirmatory test for sulfide ion. It means during qualitative analysis, if we have to detect whether any solution has sulfide ion, then what we will have to do, we have to use sodium nitroprusside. If the color of sodium nitroprusside turns from red to purple or violet, it means there is possibility of presence of sulfide ion in that particular solution, right? And oxidation state of iron in both these complexes, either sodium nitroprusside are in second complex is +2, and NO is present as NO plus. These are some important tests which are related to monodentate ligands. Is it clear?
Sir,
Okay. Now,
Yes.
again, we have learned about SCN minus, right? This is also an example, an important reason for testing of iron 2 plus and iron 3 plus, right? It means thiosulfate ion is an important compound, important species or important chemical species which is used for testing of presence of iron 2 plus and iron 3 plus. For example, iron 3 plus on reaction with SCN minus, right? Form FeSCN thrice. This is the blood red color complex. Blood red color complex. This is the iron 2 plus aqueous solution. Similarly, if we take iron 2 plus aqueous solution, this is the iron 3 plus iron 2 plus aqueous solution. Similarly, then there will be no reaction or no formation of blood red color complex. It means SCN minus can be used to identify whether in any particular solution contain iron 3 plus ion or iron 2 plus ion. So simply we can write this is used for detection of iron 2 plus and iron 3 plus in a given solution. Right? It means thiosulfate ion is important reagent that can be used for detecting that a particular solution or in any particular solution, iron is present in +3 oxidation state or iron is present in +2 oxidation state. Is it clear? If
yes,
iron
sir.
is present in +2 oxidation state, then there will be no change in color. If iron is present in +3 oxidation state, then there will be uh, there will be generation of blood red color complex. Right? This blood red color complex can be removed by addition of fluoride ion, because on addition of fluoride ion, excess fluoride ion, the iron 2 plus will react with this fluoride, which will form FeF6 3 minus and 3SCN minus, right? Also, the blood red color can be diminished or degraded by addition of Hg2 plus or reaction with Hg2 plus. There is formation of Hg, SCN twice, and iron will win like this, right? Why this is happening? It means this blood red color of complex or blood red color solution will get disappeared on addition of excess of fluoride into the solution or addition of mercury 2 plus, right? Why it is so? Listen, FeSCN thrice 6F minus. Iron is in plus 3 oxidation state. Fluoride is F minus. This is the hard base. Iron is hard acid. So there will be reaction between hard base and hard acid. So there will be formation of FeCN6 3 minus and soft base. The soft base will be remain as like this. Similarly, on reaction with mercury 2 plus, which is a kind of soft acid, there will be reaction between mercury and HCN. So the formation of Hg, HCl twice. This is soft interaction. There is hard interaction. This is also feasible. This is also feasible. This is the hard soft interaction, less feasible as compared to FeSO3 minus, also less feasible as compared to that of Hg, HCl twice. This this is the part of hard soft acid base concept. So I will tell you this about HSAV concept, right? Pearson concept. Acid base से मैं पढ़ाऊंगा तो मैं बताऊंगा, ठीक है? So what is the driving force behind these reactions? This reaction is the formation of hard interaction. It is the formation of soft interaction, right? Blood red color is due to FeSCN thrice. When FeCN thrice undergo decomposition due to formation of this and this, then blood red color of solution faded and ultimately it will get disappeared. Is it clear?
Yes, sir.
Okay. Right. So here we have to learn about how we will identify iron 3 plus iron 2 plus, right? So on reaction with HCN minus, it is forming this complex and this color is coming. However, iron 2 plus do not give any reaction with HCN minus and there is no formation of any kind of color. Okay. Now we will move to the bidentate ligands, right? Bidentate ligands. Bidentate ligand means those ligands which are attached to metal via two donor atom, right? अब उसके पास 5 डोनर एटम है कि 10 डोनर एटम, इससे मतलब नहीं हमें. इंपॉर्टेंट है वो कितने डोनर एटम से मेटल से जुड़ता है. क्लियर, राइट? सिंपल वी कैन राइट ligands which are attached to metal via two donor atom, which are attached to metal via two donor atoms. Two donor atoms are called bidentate ligand. For example, CH2, CH2, NH2. It is named as ethylene. CH2, CH2 is called ethylene. One amine is here, one amine is here. The name is what? Ethylene diamine. Single M is written here because it is the organic amine. In short form, it is written as EN. Right? Donor atom is what? Nitrogen and nitrogen. Clear? Another example of bidentate ligand is CH2, NH2, CO minus. This is called glycinate2. Right? Glycinate2. So short form is what? GLY or sometime GLY is all right. It is written as GLY. Okay. And what is the charge on GLY is -1. ये भी ध्यान रखना आपको. न्यूट्रल है, नेगेटिवली चार्ज है, ठीक है? तो ध्यान रखना GLY पे माइनस चार्ज होता है. Another example is COO minus, C double bond O minus. It is called oxalato, comes from oxalic acid. and short form is called OX, right? What is the charge on oxalato is -2. One is on this oxygen, another is on this oxygen. These are example of bidentate ligand. Here's donor atom nitrogen, oxygen. Here donor atom is oxygen and oxygen, right? So these are the common examples of bidentate ligand. Also, here this is called nitrogen, nitrogen. One pyridine, two pyridine. This is called bipyridine. Yeah, pyridyl. Bipyridyl. Short form it is named as BIPY, sometime BPY, sometime DIPY, right? BIPY, BPY, DIPY, dipyridyl, bipyridyl, BPY is the name of this. And donor atoms are nitrogen, nitrogen, right? Another common example of bidentate ligand is this. This is called phenanthroline. This is called phenanthroline. Phenanthroline, or it is called 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1 and 10. 1, 10, 1, comma 10, phenanthroline. 10 phenanthroline. Right? 110 phenanthroline. In short form, it is called PHEN or orthophenanthrophen or ophen. Right? Donor atom is what? Nitrogen and nitrogen. Both these ligands are also example of bidentate ligand. Okay? One important thing that is associated with phenanthroline is that complex of this phenanthroline is iron 2 plus Fe phenanthroline. This is important, right? Complex of phenanthroline is iron like this. This is called tris 110 phenanthroline. Tris 110 1 comma. Tris 110 phenanthroline. Phenanthroline iron 2. This complex is commercially used as redox indicator, and commercial name of this complex is, it means tris 110 phenanthroline is commercial name is called ferroin. What is the name of this complex? Is ferroin, used as commercially used as mainly used as redox indicator. It means it changes color in those reactions where there is oxidation and reduction occurs, right? On oxidation, it get converted to Fe phenanthroline thrice 3 plus. It means oxidation state of iron changes from +2 to +3, and the color of complex changes from red to blue. So when color of phenanthroline, that is ferroin, changes from red to blue, it means there is endpoint, right? Redox indicator means what? There are many reactions in which one is the oxidizing agent, another is the reducing agent, right? When reducing agent is completely reduced by oxidizing agent, or oxidizing agent is completely reduced by reducing agent, then there is change in color of ferroin indicator, suggesting that we have gotten the endpoint. Okay, is it clear? ध्यान
Yes,
रखना
sir.
है, ferroin बहुत important है. Ferroin is used as redox indicator in presence of what? Oxidizing agent CrO4 2 minus or K2Cr. These are the oxidizing agent, right? In presence of oxidizing agent, this ferroin red color converted to blue color, suggesting that end point has came, right?
सर
ठीक है, तो हम लोग यहाँ तक पढ़ते हैं. राइट। अब नेक्स्ट क्लास में हम लोग जो परसों हमारी क्लास होगी, फिर यहाँ से हम लोग कंटिन्यू करेंगे। एंड अब सभी लोग जितने भी लिगेंड्स हमने पढ़े हैं उन सबको आपको लर्न करना, ठीक है। जैसे
ओके सर।
इन अपकमिंग क्लासेस, if I write any complex for example for nomenclature, for example in order to understand stereochemistry there is number of isomerism, for in order to understand thermodynamic or kinetic stability, or in order to understand whether we have to calculate crystal field stabilization energy or color, right, or electronic spectra, then हमको आपको बताना ना पड़े कि BPY का मतलब क्या होता है, फैन का मतलब क्या होता है, राइट।
सर।
ओके,
सर।
ठीक है, तो इतना पढ़ के आना आप लोग, फिर आगे नेक्स्ट क्लास में हम लोग डिस्कस करते हैं। तो अभी ये बेसिक है, तो पहले बेसिक क्लियर कर देते हैं, फिर आपको बताएंगे PYQ कहाँ कहाँ से आप में आता है, ठीक है। तो अभी तो सिंपल आप ये इसमें नाम जान रहे हो कि लिगेंड क्या है, व्हाट इज द लिगेंड, व्हाट इज द टाइप ऑफ लिगेंड, राइट। देन आफ्टर दैट वी विल कम ऑन एप्लीकेशन, एंड एप्लीकेशन केम इन योर एग्जाम। So this is the basic of the coordination chemistry, right? Is it clear? तो एक दो क्लास में ऐसे आपको लगेगा, फिर उसके बाद फिर हम वहां पे पहुंच जाएंगे जहां से एग्जाम में क्वेश्चंस आते हैं। पहले बेस आपका क्लियर है, जिससे हमें बताने में आपको प्रॉब्लम, सो इट इज इजी फॉर अस टू अंडरस्टैंड एनीथिंग। ओके,
यस सर।
ओके
Okay,
बेटा,
sir.
थैंक यू, थैंक यू। ठीक है, फिर हम लोग मिलते हैं नेक्स्ट क्लास में। ओके, कोई डाउट
थैंक
होगा,
यू सर।
सभी लोग सुन लो, कोई डाउट होगा जितना आपने पढ़ा है, कोई डाउट होगा नेक्स्ट क्लास में, पहले मैं आपका डाउट क्लियर करूंगा, क्योंकि मैं ये चाहता हूँ कि आप जितनी भी स्टेप आगे बढ़िए, आपको सब कुछ क्लियर रहे, आपको पता रहे कि जो आप पढ़ रहे हो आपको समझ में आ रहा है, जो आप पढ़ रहे हो उसका अगर एग्जाम में आपको लिखना होगा, क्वेश्चन थोड़ा बहुत घुमा फिरा के पूछेगा, तो आप लिखोगे कैसे उसके बारे में, ठीक है। तो मेरे लिए पहली प्रियोरिटी है कि आपको समझ में आना चाहिए, राइट। और ये फेरोइन के बारे में खुद से लिख लेना, नाइट्रेट टेस्ट के बारे में खुद से लिख लेना, सोडियम नाइट्रोक्साइड टेस्ट के बारे में लिख लेना, साइनाइड जो थायोसाइनाइड टेस्ट होता है इन ऑर्डर टू आइडेंटिफाई आयरन 2 प्लस आयरन 3, उसको लिख लेना, राइट। these are these are the part of analytical chemistry, right? ओके,
Okay,
यस
sir.
सर।
ठीक है, फिर हम लोग नेक्स्ट क्लास में मिलेंगे, आई थिंक परसों, परसों मिलते हैं, इतना पढ़ के आना आपको, ठीक है।
ओके सर।
ओके, गुड नाइट, टेक केयर।
थैंक्स।
गुड नाइट।
गुड नाइट बेटा, गुड नाइट।